In this video, we are going to finish up 1410 and look at 1411. So here we were in the process of finding the centroid. So let's continue on. We needed to find the slope of AE. And upon doing so, we get 5/4. We need to find the equation of AE. Again, E is the midpoint of BC. So we can write that in point slope form, picking one of these 2 points. So let's say we pick E. So y minus 4 equals 5/4, parentheses x plus 3. Distributing and adding the 4 would then get us to slope intercept form of y equals 5/4 x plus 31/4. So then at this point, we can just go ahead and solve the system. So these are the 2 equations we're going to be using. So we can go ahead and set them equal to each other since they're already both set equal to y. We can just substitute in the 2x plus 9 in the y over here in this other equation. So we're going to have 2x plus 9 equals 5/4 x plus 31/4. And then our goal is to go ahead and solve for x. So because we have division by 4, we might choose to clear the fractions by multiplying everything through by 4. And then we get 8x plus 36 equals 5x plus 31. And then we can combine like terms. So subtract the 5x maybe over onto the left side and subtract the 36 over. So we would get 3x equals -5. So then x is -5/3. And taking that, subbing it back in to either of the 2 equations, maybe this one because it doesn't have the fractions, and solve for y, and you get the point -5/3, 17/3, and that is the point of concurrency for the centroids, called the centroid. Okay, so we're going to take a look at continuing on 14-11. So these are just right in here in your Canvas in modules, so at the bottom there. So we'll walk through them. So this first one is a hexagon. We're constructing a hexagon inscribed in a circle. So that just basically means inside of a circle. So here we go. We start with a circle. We know the center. So you just construct that with your compass. The compass on the point set its width to O. So you would just stretch it out from here to here to see how far that distance is for that radius. It's showing it for us. Move the compass to a new vertex. So you keep the compass here, and that would be where the point is located. And let's see. One moment here. Okay, let's Let's see if it's just a small issue. Okay, there we go. So we're going to use that distance in order to mark around the circle at that same distance, which was the radius. And notice how the compass just continues moving across the way. And then, since that is basically broken up the 360 degrees equally, so remember yesterday what we said, a central angle is equal to the arc it intercepts. So if I go ahead and make this central angle with the angle at the center, then that would be 60 degrees. So that would be cutting off a 60-degree arc of the circle. So in this case, it would be 60 added to itself 6 times, which would take us around all of that entire circle. So we basically broke up the circle into 6 equal distances. Okay, and it works that way because when you do create this central angle, you're going to have the length of the radius equal to the length of this side that you're going to have here, because you will have an equilateral triangle inside. As I'm using my pointer here to show you how that will look like. So there we go. Inscribed means all of these points will actually be touching the circle. So that's how you know this has successfully been inscribed in a circle. We're going to do the equilateral triangle inscribed in a circle. So you make that circle. With a compass on a point, set the width to O. So similar start to the previous. And we stretch it out. Looks like, again, we're having some technical difficulty. So let me just refresh here. Okay, stretch it out. There we go. Okay, so you mark it from that same point that you used to stretch it. You mark 1, 2, 3, 4, 5, and then 6 being that original point that we started with. And so in this case, instead of connecting each of the intersections, we're going to connect every other. Okay, and upon doing that, we will have 60, 60, and 60. So this will be a 60-degree angle intercepting the arc it is across from, which is 120 degrees. So it's half. We were talking about that yesterday. Half of that 120 makes this 60. Similarly here and similarly there. And last one, square inscribed in a circle. So we start by creating the diameter, which means connect the center and 2 points on the circle. Draw an arc above and below. So you stretch it past the radius. So it looks like it's trying to create the perpendicular bisector here. And then you connect all the way through. You have that 90 degrees. So we know in a square, the diagonals are perpendicular bisectors of each other. And then you can just go ahead and connect the endpoints as it does here. And now you have a square. And that takes us through all 3 on 14-11.